Hi, welcome to Glass Academy. Today we are going to learn about tempering, a process all about how it is taking place at the processor place. Let's look at it agenda first. Upon completing this model, you will be able to answer what is the difference between annealed glass and tempered glass and purpose of thermal treatment, basically heat treatment, tempering process, list of various types of tempering process, do's and don'ts, common defects, and test as per the EN standard. So this is today what we are going to discuss about. So let's begin. So as you all know about it, how the float glass manufacturing process. So this is a schematic diagram for a float glass process, where this is the annealing layer it starts. So why people are calling it annealed glass? Because the annealing process takes place at the time of manufacturing of the raw glass. So annealing process is nothing but when the hot temperature goes into the cold medium, which is very much a slower phase. Thereby you are getting the induced internal stress, thereby getting attained into the glass. So annealing process is a very slow cooling process, certain controlled, subject to control and pressure and temperature. What is spin wave float glass? People would ask you, because float glass is nothing but flat glass, or you can say it's annealed glass with a raw glass during manufacturing process, which is called because the molten stage of the glass has been placed on the tin bath. The tin is a medium where the glass which is transmitting to one place to another place, which is floating across. So that's why it is called the float glass. Annealing float glass is a process is controlled and cooling to prevent residual stress in the glass. It is a part of the float glass manufacturing process. Annealed glass can be cut, machined or drilled, etched process, polished, or heat treatment can be done, or lamination. All other process can be done. To anneal the glass is heated and kept for a defined period of the time to relieve the internal stresses. Carefully cooled under the controlled conditions to ensure that no stress are reinduced by chilling and cooling. So this is the annealing glass. So let's move on. What is why we need to use as a tempered glass? What is the purpose of using the tempered glass? So to improve mechanical strength and thermal shock resistance. So mechanical strength, which is nothing but tensile strength and compressive strength and bending strength. Thermal shock resistance, which is there will be a temperature differences causes will have a glass breakages. In order to prevent this thermal shock, we have to temper the glass. And most important, widely normally people would call the tempered glass is a safety glass. Yes, so the tempering process which help to attain the specific characteristics is one of the best characteristics to safeguard our people who are working there, so it won't harm anybody. So safety aspect, it will improve the safety aspect of the glass. So there are two purposes basically why we have to tempering. One is improve the mechanical strength and the thermal shock resistance, and most important to increase the safety aspect of the glass. Yeah, let's move. You see that there are glasses glazed on the windows. You see that tensile and surface flaws also mentioned over there, and the below pictures are mentioned 50 degrees centigrade. The glass, annealed glass, if it is uses, it will resist up to 50 degrees centigrade, beyond which it will breaks. So annealed glass, on the bottommost right hand side, which you will able to see, which is the breakage fragmentation. If the annealed glass broke, how it looked like this. So these are the pictures of illumination. So let's move on. What is tempering? So tempering is a process which stress is developed in the glass to increase mechanical strength 4 to 5 times than the annealed glass. That is, the mechanical strength tempered glass equal 4 times of annealed glass, basically to increase the tensile and compressive strength of the glass. You see the range of the tempering range high. So this is the place where tempering range starts here. You can see the strain point, annealing point here. So which means glass subject to heated up to 600 to 700 degrees centigrade, where the curve is started. This is the fragmentation pattern of the tempered glass. Why need of the thermal glass? The left hand side you see the annealed glass fragmentation, which is harm the people because the very basically it is sharp in nature. It will hurt the people. To in order to avoid that breakage event, so we have to increase this strength of the glass. You see that the fragmentation patterns completely differs from left hand side to right hand side. The right hand side picture is what you see, that is fragmented, which has dull edges. If the glass broken, it won't hurt anybody. So that's the picture it says for us. And basic mode of heat transfer, as you all know, it's convection and conduction, convection, radiations. So let us discuss the basic concept of heat transfer, which is takes place at the tempering plant. So before get into the tempering process, this is the basic step which we have to understand, which is the conduction, convection, radiations. So conduction, which is nothing but the heat which is been felt or the transmitted, the medium is any form of medium. So imagine any iron rod which is tipped or the edges are heated up. The slowly you get the feel of the heat at the tail end of the rod, which means you will be that the heat is been moved from one place to another through any medium which is iron rod. So if you say that 100% of heating process, 100 degrees centigrade when you are at the tip of the iron rod, when you feel the tail, it won't be 100 degrees centigrade. Maybe it's a 50 degrees centigrade, 40 degrees centigrade because of the heat loss. So considerably we are getting the heat loss at the conduction process. Let's see the radiation process. The flame is there. People are the finger where you are getting the heat is been felt because of the electromagnetic waves. The glass, the heat is transferred from one place to another through electromagnetic waves, which is called radiation process. Whereas convection process, you see that, and this if the flame is completely transmitted to the other, the heat is completely transmitted through air molecules, and air is present. So the heat is capture the air and it will flames further. It gives a more efficient energy transform from one place to other through air medium. So which is convection is the best medium as far as the mode of heat transfer. So that's why in tempering process, convection is most widely used in all of the latest tempering machines. I hope you all understood what the basic mode of heat transfer. So why I'm emphasizing here, so if you understand this, you can understand better in the process of tempering. So let's move on. Types of tempering. Tempering divided into two types. One is thermal tempering and chemical tempering. And further, thermal tempering divided into two types. One is horizontal and vertical tempering. And again, horizontal tempering divided into two types. One is batch single two-stage chamber or continuous chamber. Thermal tempering process. Having said that earlier, thermal tempering is the process in which glass is subject to controlled heating and cooling in order to significant increase in the resistance to the mechanical and thermal stresses. Thereby you are getting the required breakage characteristics through this process. So basically the heat and pressure which is widely used for tempering process, the heat is powerful medium and air is powerful medium in this here, which is involved. How fast you are cooling the glass, you will be getting this tempered glass, which means the surface compressions rendered on the glass is faster, which is take place on the tempering process. So we'll see the further characteristics of thermally tempered glass. Some of the characteristics of glass after thermal tempering are the color, clarity, chemical compositions, light transmission, hardness, solar properties which will not changes at all. If you do it tempering, it will be remain same forever. There is no changes at all on it. The physical properties such as flexural strength, tensile strength, compressive strength, definitely it will change. That's the need for tempering of why we are doing it. There is improved resistance to the thermal stress and shock proof resistance. Thermal stress is most important. For example, if you use annealed glass on this facade or windows, the thermal differential between this edges and the mid plate, it causes the breakages, which is called thermal breakages. Obviously taken place with help of 50 degrees centigrade. Within that it will breaks. In order to avoid that, so we have to do a tempering process. So this is one of the characteristics of thermally tempered glasses. Breakage pattern also changes. Yes, obviously this would change this breakage pattern as well. Annealed glass has a sharp edges. It will hurt the human beings who works near the working areas. Whereas tempered glass breaks this, it won't hurt anybody because it has a dull edges. It's kind of roughly it's a kind of dull cubical particles where it won't hurt. So which we have seen here. So let us look at it. What is tempering? How it is taking place? So what is the mode of heating transfer? So far we have learned about it. Let us look at it. This is the schematic diagram of tempering plant. It is widely used. This is called the horizontal tempering machine, where you can see the first portion is loading, where you have to load the glass with respect to the sizes of your orders, or with respect to size of the how much it can be handled. So loading can be, which means before tempering as annealed glass, after washing all the door, grinding, polishing, drilling, everything's over. The first step is you have to keep it on the loading phase, where annealed glass, float glass, flat glass are kept on the loading table. And next it is set of phase called the heating chamber. This is vital, playing a role in terms of tempering process. Heating is most important process in terms of tempering. And the next phase is quenching cooling, where this special characteristics of tempering like surface compressions and mechanical strength, which will attain at the phase it in quenching and cooling phase. The next phase is unloading phase. So which means there are 4 stages of tempering process: loading, heating, quenching and cooling, and unloading process. So upcoming slides we are going to discuss about in detail in these sections of tempering machine. Let's see how heating taking place at the heating chamber. You see that you are heating the glass up to 600 to 700 degrees centigrade. It depends upon the manufacturer. The temperature will be differs because what is the distance between the glass kept on the rollers and the heating coils and the heaters are produced over there. So depends upon the manufacturer, it may vary. So that's why it's heating up to 600 to 700 degrees centigrade. You are heating the glass on it. So if you want to do it tempered glass, thereby you have to do a rapid cooling, which means a fast cooling on the surfaces. You see the difference between the 2 images. The first image is completely heated up to 700 degrees centigrade, which is obviously it's a red color. Where you can see there's a below second picture. After rapid cooling, the surface compressions is rendered on the surfaces where the top and bottom, which means the glass has a phase 2 phases. One is phase 1 and phase 2, which means air side and tensile, or you can say at the center still the heat is there. So that is the causing the tensile strength which is playing across here. You see the graph which I showed you with respect to before. You see that the same temperature playing a major role here. So after surface compression rendered, you see that the red color glass would become a blue color. I mean, I'm just explaining the process, how it changes. It's not like blue color when you tempering it. In order to clarify you, I made it as a blue color, so that's why. So in the blue region where you see that the 0.2 region, that is a compression zones, because the surface compression is rendered on the top, because the faster when you go rapid cooling, the surface is getting the heated up first, so those areas like phase 1, phase 2, it's easily get cooled up because of the rapid cooling. And this where 0.6, that's a zone called tensile zone, and again it's a 0.20 compressive zone. The stress pattern is developed after process. I'll explain you in a bit manner. When the glass is cooled quickly from liquid stage to glass stage, the density difference develops between the surface of the mid plate. So mid plates, it takes longer time to cure, whereas surface is faster to cure. This happens due to the low heat conductivity of the glass. The surface is illuminated here by the line A and mid plate line by B segment B, you can see through here. So this is the line which I am saying about it, and you see that this is the topmost portion where the surface compression is rendered, and this is the mid plate where your tensile zone is taking place. The density difference is caused by a different rate of cooling surfaces mid plate. The rapid cooling, the glass surface is solidified, became the hard, so that the molecules cannot no longer rearrange themselves. In this manner, they form permanent bonds. So let's move on. Chemical tempering. Basically, this chemical tempering is widely used for thinner glasses, not for the thicker glasses as of now, and this is for small batches. It cannot be used to mass productions because limited space of this apparatus or machines to be used for this. Mostly this is widely used for mobile phones, watches, which you cannot fed as a furnace into furnace, because roller distance is 150 mm, where the small size glass or lesser thickness where you are not able to fed to the furnace. Those glasses can be tempered with help of chemical process. Mobile for tempered glass for mobile applications, for in order to avoid the scratch, or if it is falls from one place to other, it won't shatter proof. So those applications widely used chemical tempering process. So let us look at it, what is happening inside of this chemical tempering. So chemical tempering is a process in which the glass is fortified using the ion exchange method, wherein sodium in the glass is replaced with potassium. Basically, sodium and potassium exchange their molecules. The process is used when extremely thin glass is needed to increase strength is required. Having said earlier, this process widely used for the thinner glasses, which you are not able to do it on the horizontal tempering, which means that heat treatment, thermal tempering process. As a result of this process offers an increased surface compression that strengthens the glass without creating the distortion, and the glass surface is rendered harder and more resistant to the scratching. This is the most important for thinner glass application, where the scratch proof like watches, very small tiny watches, will have see the scratch proof resistant watches. How it is possible? Because it's basically this a glass. In order to avoid the scratch, so you have to do a chemical tempering. So those words, whenever you come across the scratch proof, so basically those watches glasses are used to chemical tempering. With the chemical temper glass, there is no risk of spontaneous breakages. This is one of the ideal solution for tempering process. Whereas tempering process, ion exchange method is the best process for the thinner glasses for that. So let us look at it, the process. The glass is immersed in a salt bath at a 400 degrees centigrade for 12 to 36 hours. It depends upon the load, how much you are keeping the load. duration would be varied. The ion exchange between the potassium sodium gives rises to the molecule each other, and thereby the compression on the surface of the glass is been rendered. So this is the process of chemical tempering. Let's move on to do's and don'ts tempering. All the cutting, drilling, grinding should be done before tempering operations. Correct temperature and pressure should be fed as a recipe according to the thickness of the furnace. For example, if the one processor who has the recipe of that 6 mm clear glass cannot be put as a same recipe as for other furnaces, or even Louis glass, if you're using it, the same setup parameters cannot be used for the other machines, because if the furnace to furnace it will vary. But we have to keep in mind at the time of during validation, or when you do this testing trial, you have to understand what the best recipe out of which you can get out from your machines. For coated glasses, coated side should not be placed on the roller face, because the coating would damages and roller get damages. Thereby nothing, when coating it go away, you will have more scratches and performance would not be get from this coated surfaces. So all the times, whatever your since from the crate opening, which means cutting, pre-processing like grinding, washing, drilling, and tempering, all the coated products should be always fed as a top side of the coat facing on the air side. Basically, it should not be in contact with the rollers. Post tempering, glass quality has to be checked according to the recipe, must be varied, and you can check with that. You can check the quality in terms of tempering parameters. If anything is obvious which is not acceptable for your naked eyes, so we can eliminate those with help of tempering parameters, or else there is a EN standard, European standard EN 12150, which will help us set of quality what we are expecting for particular projects. Glass with its side chip off should not be placed in the furnace. If you keep this chip off this one, it will break into the chiller during the chilling operation, which is a quenching operation. The glass would break, so that's the one.